Hey guys, gosh darn it, this thing is getting dirtier and dirtier every time I try and film something. And I also smashed my phone, so I have a giant crack running down the middle of the screen now. At least the camera still works. So, remember last video was all about that image intensifier thing that I found, and it didn't do as well as I hoped it would. But anyway, I hope it was interesting, and the ones of you who watched it, I hope you enjoyed it. But as I said, I did find several more things at the flea market last week, and I'm not sure if I'll be able to make it this week. So I thought about we'd take a look at the rest of the things I found last week and call it a bonus material. How about that? So let me get the things um, from the various places they've actually teleported to in my absence this week. So, and bring them here and we'll discuss. So first item on the list was I don't know why I got this thing, but it proved to be quite an interesting bit of educational information you can find in here. So this is a contactor, basically. It's a big relay, and it's usually used in stuff like industrial automation. So this is actually a motor starter contactor. So it's meant to start up an asynchronous motor, usually like, I don't know, the kind you'd find in like a big lathe or a big drill press, industrial sort of machinery, or a table saw, or a conveyor belt, or something like that. Excuse me. So these are actually just switches, and they run on 24 volts AC for this one. So you can see the coil says 24 volts AC, 50 or 60 hertz. And they usually have this weird, like, convention of numbering the terminals. So usually coils are number letters. They're usually A terminals, and then there's other letters for different terminals, like the main contacts and auxiliary contacts, like these ones. So this thing basically is just a three-phase contactor, three-phase relay. It has one normally closed contact, and three normally open contacts. So when you actuate the coil, it pulls on this thing down, and it breaks these contacts and makes the other three. Why did I get this thing? Because it's just a big relay, right? Well, I wanted to show you one cool piece of technology and basically physics they use in these things to make them work. So first of all, these are meant to open and close inductive loads. And anybody who's ever tried to start a big induction motor or anything, even if you try to plug in your laptop charger into the wall outlet, that's a different kind of load, but you're going to see that there are some sparks. So what's happening with most big reactive loads is that when you connect them to a power supply, they kind of act like a short circuit for a little while. And when they act like a short circuit, they're going to be able to, they're going to pull way too much current through the wires, much more, like over 5 times as more current as their steady rate current from the mains. First of all, the mains has to be able to deliver that current, and it usually does in industrial settings. But the second most important thing is that the contactor has to be able to withstand this thing. So you're going to see on the plate right here that this contactor is rated to start up to a 5.5 kilowatt asynchronous motor. So a 7.5 horsepower three-phase motor on 600 volts. You can see that the lower you go in voltage, the lower basically the power you can have running through this thing. Of course, like you can only have the same rated current. So if you go down in voltage, you're gonna drop in power, of course, right? Okay, so What's this weird piece of technology I wanted to show you? Well, first of all, you can see here that this thing can make a 7200 VA circuit and break a 720 VA circuit. What does this mean? Well, making is very easy. You just slam contacts together shut as fast as possible. Breaking a circuit is much more difficult, especially when it comes to inductive or reactive loads in general. And it's even worse in DC. So if you have a high power DC circuit running and you want to stop it, and there's any length of wire, once you try and disconnect the two switches, the two contacts, when they separate, there's gonna be an arc that forms between the contacts, right? And that arc is vicious. So the plasma in there is many times as hot as the Earth's core, and it's very destructive. It spreads out and it engulfs everything in flames immediately. So usually contactors have quenching chambers. So quenching is the act of extinguishing an electric arc, basically. And in DC, it's much more important than in AC, because in DC, the current never goes through zero. It's steady, right? In AC, you have sort of an advantage. The current and the voltage go through zero 60 or 100 or 120 times a second. So 50 or 60 hertz. There's 2 zero crossings per period. So the current will go through zero, giving the arc a chance to quench itself. But that's not what usually happens. Usually the arc is so hot and so vicious that once the voltage goes above zero again, it reignites. So that's one thing you don't ever want to have happen. So larger contactors, this one doesn't really have any quenching media or quenching facilities. Larger contactors have quenching chambers, and usually circuit interrupters and stuff like that have extremely large quenching chambers meant to handle very vicious arcs. So yeah, high power electricity isn't very, it's very fun, but it's not fun at all. Like, it's very dangerous. The second thing that is interesting in contactors, especially contactors that have AC coils, is, well, I just told you that the current will go through zero 60 or 120 times, 50 or 60, so 100 or 120 times a second. So if you have a winding on an iron core, basically, or on a magnetic core, and you put current through this winding, you're going to create a magnetic field through the, or actually a magnetic flux through this core. So the magnetic flux is proportional to the current and the number of turns, but we're going to assume the number of turns stays constant. So that magnetic flux would also go through zero every time the voltage, actually the current goes through zero, so 100 or 120 times a second. So this thing, if not for what I'm going to show you soon, will have the contacts ever so slightly separating and slamming back together 100 or 120 times a second. So what do you do to prevent that? Well, if we take this other piece of the armature here, this is called an armature, you can see that these things mate, but there's a slight difference in their construction. So you can see this thing here is missing this thing here. And if you look closely, these two things are what they call shorted turns, basically. So it's a shorted magnetic shunt, and it creates a phase-shifted magnetic field through the core in order to ensure that the sum of the main field generated by this coil and the field which is generated by this shorted winding never goes below zero. So it will always be higher than zero. So the force that's acting on this armature to close it down and to close the contacts will always be higher than zero. And that actually stops the thing from buzzing around. All right, so that's about 10 minutes worth of talking about contactors. I'm not mad at all if you decide to skip that. So without further ado, I'm gonna put this thing back together and get to the next topic. Give me just a second. Alrighty, so actually I kind of screwed up, and this is the second take. So a couple of weeks ago, I got something along the same lines as that Russian microcalculator, and it actually didn't work, so I had to fix it, and it took me until last Thursday to get the parts in here, like the replacement part, and to get it fully working. But ta-da! This is a very weird thing. It's the first one I've ever seen. It's a Felix, so this is a Romanian thing. It's a calculator electronic, so electronic calculator. I30P. P stands for programmable. So this is a programmable calculator. I have no idea how it works or what it does. It's got the worst numpad I've ever seen, and apparently it's doing some sort of a loop now. I don't know if you can see it, but it's probably broken. I've probably broken something, and it's gone horribly wrong. It's sort of like you have to program it in something like a machine language. It has some registers that I could convince to pop up, and I have no idea what it's supposed to do. It's probably something like a scientific calculator to help you find something like to plot a function, but not actually plot it, more like find a minimum or a maximum or something like that. I have no idea. It's for various mathematical, scientifical things. So what was wrong with this? So I turn it on, like carefully. 30-year-old electrolytic capacitor stench in your bedroom isn't that great. So I turn it on carefully. It didn't pop, which was surprising because most Romanian made capacitors have failed long before I was born. So that's another jab at Romanian industry. So I started measuring some voltages around. Everything seemed to be fine. It has almost a 30-volt rail for the VFD and a negative something rail for the logic. I think it's all negative logic, so it's grounded and everything goes negative. I'm not entirely sure. And there's another rail which is the 6.3 volt filament for the VFD. And everything checked out fine. And then I had looked at the filament, and yeah, it was shot. There was no filament left, and it was dangling everywhere. So I actually found replacements, and I got two of them. So this is a Soviet-made VFD. It's very pretty. You can see the metallizing from the backside here. And if you look closely, you're going to be able to see that it's a IVL 1-8/13 something, made in the USSR. That's what those characters there mean. So something SSSR, Soviet Socialist Republic, etc. You know what I mean. And OTK here means quality control, basically. And this was quality controlled in 1992. So this is 3 years older than I am. And these are the getters. So these are flashed using an induction heater while these things are vacuumed to suck any impurities, basically, to improve the vacuum and the thing. And if you see these things go white, then it means that the tube is leaky and it's probably gonna die, or actually it's actually dead. And we can see that all the segments for the display digits are paralleled, and you can select the grid for one display, and you can turn one digit 1 and multiplex it to the next digits. Just a second, I have to convince one of the cats to stop eating the food for the other cats. Be right back. So speaking about the cats, sorry. The two smaller ones, I actually had another 2 cats and a dog. Long story. The two smaller ones are fully perfectly functioning, like they're very healthy now and they're extremely playful and they've grown a lot. And the other ones have some problems with their livers or something, like gee whiz, I have no idea what. And they're supposed to be on some sort of diet food. And of course they hate the diet food, so they're eating the small kittens, like the kittens food, right? What are you gonna do? Anyway, let's get back to this thing. So this is meant to be multiplexed, and yeah, let me tell you, getting the old one out, desoldering it wasn't gonna happen. So I just snipped off all the pins, cleaned out the holes, putting these ones back in. That nearly done me in, like nearly did me in completely. It was a nightmare. So the PCB is very poor quality. It's some sort of phenolic paper and it just wants to delaminate under the slightest touch. I don't think the holes are plated through. I think there are no vias except where there's a pin going through from top to bottom. Jesus Christ. Anyway, you can see it working. I'll look for a manual and try and see if I can make it do something funny. Count at least or something like that, but that's for a different day. Okay, so this is the Felix. Next thing I wanted to show you is coming right up. Be right back. So this one isn't very special, but it's a bit of a jewelry, like a jewel, a mechanical jewel. So this is a Swiss-made gear motor. So it's a Faulhaber motor with a mini motor as a, you can see it right here, gearbox on it. So it's one of those extremely fancy precious metal brush, very finely made, exquisite quality DC motors. And these things are like, they're an arm and a leg if you buy them new. They're like over 400 or 500 euros for one of these things, I assume, with the gearbox on it. Yeah, I got it for free basically because the guy just told me pick one more thing. He was shortchanged and pick one more thing, and I said, how much for this? You can take it. And how am I gonna, like, how am I not going to take a Faulhaber motor with a mini motor gearbox on it? So it's just great. So I'm not entirely sure how to take this apart, and frankly I don't really want to take it apart. So this is you can see on the back side here it says made in Germany. So the motor is Faulhaber right there. I'm not sure if I'm pronouncing that right. What are these things? These are medical grade motors, I'm assuming. Medical or very fine industrial stuff like semiconductor manufacturer stuff like that. They're very low noise, low vibration, and they're meant to be very reliable. So I once worked on a remote control for an implant that had a Faulhaber actuator inside, and that's all I really cared to tell you about. For fear of not getting into trouble. So it wasn't a straight motor, it had like a pull and pushy thing, and that's it. You wouldn't put anything else in an implant, something like Maxon or Faulhaber or something like that. Anything else is just a risk you wouldn't really want to take. And I'm pretty sure that these guys actually have pre-qualified things for like implants. So yeah, exquisite quality. If you can find these, I mean, I'm never gonna find the same, like another one of the same kind, you know, but it's a great thing to have in a parts bin just for an added touch of pizzazz. If you're making that one lazy Susan that's meant for, like, you know, spinning a thing very gently and very elegantly, this would be great. And you could say, look, I used only the finest Swiss-made parts in this thing. So yeah. Also, I worked on another thing, and I'm really not sure if I should be telling you this, guys, but there's a product you can actually buy on the market right now that I made hundreds of. I think you can still buy them. They might have gone out of business. It's something that measures something on your body. That's all I'm gonna say. Thing had a darned made in Switzerland sign on it. We printed those things on it, we printed the sign on a printer in Bucharest. So I'm not sure how kosher that thing is, but I'm not gonna tell you who did that. Or anyway, I think they were kind of doomed to fail. So this was back in the days where one of my previous jobs. So never trust anything else. I would never trust anything to be truly made in Switzerland unless it's a Swiss watch, and I honestly hesitate even there. So, or Sheldon. So they are still made in Beviard, I think, somewhere on the Valley of the Watches, Vallée du Jour, if I'm not mistaken. So, Sheldon and Swiss watches. So yeah, these things are also probably made there as well. But consumer goods, nah, screw it. Don't buy into that. Okay, I am trying to stop rambling, but I'm failing miserably. So, by the way, if I'm ever gonna get to 1,000 subscribers, I'm going to need some questions for Q&A. So I would be very grateful if you could leave some comments down below for when that happens in a year or so or something like that. Thanks. I'll be right back with the next item. Ah, yes. I forgot. I took some of the things apart, and I'm sorry, you're gonna have to forgive me for enjoying the teardowns by myself. But I still have a few things to tell you about the things that I found. So first of all, I found a camera, one of those CCTV cameras. You can see there's a sensor here. It was one of those C-mount thingies. And the guy was very dismissive about their quality, but I was pleasantly surprised about the construction of these things. It's really, really good. So first of all, die cast. By the way, it didn't look much better than this one I got them. So die cast enclosure. Imager, and this is an interface board. It has a BNC for the video out and some connections and a dip switch and another rotary switch for shutter speed and stuff like that. So very pretty. I love these Sony sensors. This is an actual Sony sensor, and there's the decoupling for it and local regulation, I assume. Actually, no, there's no LDO around here, but anyway, you can understand. There's a flat flex and a power pigtail that came to here, and nice little bodge because apparently it needed more capacitance then. So yeah. By the way, CCDs are very difficult to read quickly because of the fact that they're giant capacitors, and draining charge of a capacitor is kind of difficult. So it's not actually about the reading part, it's about the resetting of it, all the buckets of charge. So basically how one of these things works is there's a matrix of capacitor plates, and they're charged by photoelectric effect basically, and then you read the voltage on those things. This is very low, like airplane level observations of how a CCD works. And then you take a fast ADC and you scan and read all the pixels individually, and you select which pixel through some of the pins on the thing itself, I assume. And then you debayer it, or actually no, you just put it into a matrix if it's a monochrome sensor, and if you need to make a color sensor, you will have to read 3 pixels for each. 3 values for each pixels, basically. Red, green, and blue. But anyway, what I wanted to show you about this camera is this is a very nice power supply for a consumer item. So Nippon Chemicon capacitors, and a very nicely made PCB. Lots of clearance here. And yeah, it's a dual output power supply. It's 5 volts at some current and 12 volts at another current, and 7 watts maximum power supply. This would be great for a small project, something like that. So I'm keeping this. It definitely works because yeah, the camera itself still works, the guy told me. Okay, it's gonna be a bit of a quick fire round. Next thing, I found a Quantum Bigfoot hard drive and realized that hard drives are far too shiny to be shot on YouTube when you want to stay a hands channel. So this is just the read head from the Quantum Bigfoot. I don't know where I first heard of Quantum Bigfoot hard drives, but they were always like famous in my head. So you can see there's the itty bitty, with actually giant read head. I'm gonna try and insert a photo under the microscope of these things. But basically what these are is just 2 coils of wire which are floating over the surface of the platter while the platter is spinning. This voice coil moves it back and forth around this central pivot here, which has some bearings in it. It actually has some very nice bearings. And this is the thing that does the reading and writing of the basically the bits of information stored on the hard drive. And last but not least, and this is the only thing I have left of them because it was just too much, absolutely much too much stuff to talk about. Actually, no. I told you Grandpa Simpson has gotten nothing on me. So, where do you think these things come from? I'll give you a minute to post your comment, and then I'll give you another minute to edit the comment and claim you're right. Right, so these come from a tape drive, like a, server mainframe storage tape drive kind of thing. Hold on a second, let me bring the other one because, I bought 2 of them because the guy said he had 2, and what I was going to do, have one to take apart and not have another to show you guys? Be right back. Alright, so here it is. It's a Dell. Funnily enough, it's made in China for Dell by Tandberg Data. Now, I might be wrong, and I'm going to put an annotation here and tell you if I'm wrong, but Tandberg actually made reel-to-reel players, if I'm not mistaken, and I'm under the impression that they were really good. So this is a SCSI, and I have the controller card for it somewhere around here. Gave me the full kit and caboodle, kit and caboodle. What the hell is going on with me? It's Friday evening. I've been working all week. I'm tired. So, SCSI interface, and the guy swore on his mother, which is a Romanian custom, that these things work. And I trust him because everything he sold me claiming it was functional was actually functional. That might be a mistake though, because this looks extremely dirty inside. Anyway, it's an Ultrium. So I think this is actually still, you can get tapes for this, and you can get massive amounts of data stored in one of those tapes if you compress it hard enough. So these are meant for archival storage. If you it's not kind of like a data that you need to get to quickly, because imagine there's a cassette tape inside that needs to have a head ran across it, and then you need to go to the right place on the tape and read the data, and it's very slow, and have to read it back and write it, and it's not a fast storage media, but boy does it have capacity per dollar. This thing, the tape is still the best bang for buck when it comes to gigabytes per cent or something like that. The cheapest, by far the cheapest. And Tandberg, they did a very good job. This thing was very nicely built. I'm not going to take this one apart because it's kind of destructive. There's some stakes in here that are, I think, staked after the cover is put in, or I didn't know how to take it apart. But I needless to say, I completely broke the other one. So these are a couple of very nice BLDC motors. Basically, they're three-phase so permanent magnet synchronous motors, and they have 3 fat traces on that kept on basically on that flex circuit. 3 fat traces for the windings, and several more for the 3 Hall sensors I'm expecting to have inside for positioning. So these are actually meant to, one of them spins the what do you call it, the capstan and or something like that, and the other one spins the drum inside that unwinds the tape in order for it to be dragged over the reed head. So yeah, archival storage, and if this thing works, who knows? I don't know why I got this thing, man. Like I got 2 DC motors out of it. But it's interesting. So actually, one of my previous jobs, they used before passing on to like Google Drive or Cloud or OneDrive or something. I don't know. They still used to back up all the data daily on tape drives. And I regret not taking the server they had for backup because they scrapped it. And they had 2 of these, 2 of those like Dell 2U height old Xeon dust buckets basically. But they had a lot of tape drives, and they had a lot of tape. So I could just wipe that tape and have like archival storage for years and years. That's a very stupid train of thought I just went on. Like, I'm sorry, it's completely ridiculous. But anyway, yeah, tape storage. And I have one more thing to show you, and this is another cute contactor. This one is actually so small that I could take it apart with your nails. And why did I like this thing? Because I might do something with it in the future. I'm gonna ruin my nails live on camera for everybody to see. Hey, here we go. So you can see the mechanism inside. This is one of the nicest mechanisms, like most intuitively easy to explain mechanisms I've ever seen. So you have 2 contacts normally open, they close when they're bridged by that copper bridge right there with contacts. And you can even see, I hope you can see, that the contacts aren't actually the freshest. So yeah, this is basically a 240 volt contactor for something, and it actually works. It's still got some life on it. And I remember when I was in college back in the day, years ago, when I was studying a discipline called so by the way, let's do a bit of a tangent. So I studied electrical engineering. I'm an, what do you call it? An EE, just a plain EE, an electrical engineer, like Electroboom. He's got a master's degree. I gave up on that. And I'll tell you why. So the university in Romania is very weird. So there's 4 years, and you end up as an engineer, but those 4 years are structured very weirdly. So first 2 years, they dump a whole load of maths and physics and calculus, like we had calculus and algebra and physics, basically sort of like physics 101 and chemistry 101, and some basic circuit theory, like they're teaching you Ohm's law basically, and Kirchhoff's voltage law, and KVL basically, and the other one, which is Kirchhoff's current law. The sum of currents in a node is 0. going in and out of a node is 0. So they teach you all these things, and they expect you to master, because professors in Romania, there are very few of them who are dedicated to their craft, basically, because it's one of the more arty disciplines in life. You kind of need to have a gift to be a teacher, a good teacher. So they teach us all this maths and rubbish physics. So I did optical. I only did 1 semester of physics, and it was all about optics. And I never did anything related to optics in university ever again. So the first 2 years, they pump you up with some basic disciplines, like as I told you previously. The next 2 years, holy goddamn, how do you explain this? So when you finish second year, depending on how good your grades are, you can choose between 2 specializations, or you can go 2 ways. So actually a bit more, but there were 2 main ones for our university. So it was power electronics and I have forgot the name, but it was something with power electronics, the one I did. And there was another one which was called electric systems. What the hell does that even mean? Like, goddamn. So at power electronics, sorry about the hand again. So in power electronics, they started teaching us about electric machines first. First useful course was about electric machines. So transformers, synchronous motors, asynchronous motors, and stuff like that, right? That was pretty interesting, but the motors we were doing the lab work on were 40 or 50 or 60 years old. Imagine that. I think I'm gonna insert some photos. If I can find a few photos about those things. There were some newer stands that the university had purchased, like electric motor test benches. There was a DC motor and a asynchronous DC motor and a synchronous motor to be used as a motor and generator. So you could study the characteristics of a DC motor and the characteristics of a synchronous generator, or 2 DC motors hooked up, so you could study all the configurations a DC motor can run, and like feel like series wound, parallel wound, etc. independently excited, etc., etc. So basically what we would do would be to crank up those things, power those things on, and measure the behavior of those things. So that was the first useful thing. I failed that miserably because I argued with the professor. I completely and utterly failed it, like really bad grade. Next, I'm getting all emotional right now. Next discipline we had with the same professor was it wasn't field-oriented control. It was transitory regime, like, what do you call it? Dynamics of machines, of electrical machines. So how do you behave in when you turn them on, turn them off, apply load steps and other stuff like that. It was an entire semester of MATLAB Simulink. So that was all, like, and the courses were incredibly difficult, like inordinate amounts of maths, and I understand that you would need to learn that, and this is where I'm kind of heading with all of this thing. So I regret doing that university. I regret not going somewhere else. But what I'm beating at is university in Romania is very, very weird. So I heard that, first of all, in the United States or other countries, you can choose what courses you go to. There are some obviously necessary things to finish, but you can choose what you want to learn. Second of all, and goddamn, we had around 24 disciplines per year. So over seven or eight exams in a semester. So half a year basically, and we had 24 or 25 disciplines in each year, and those disciplines range from as I told you, maths to field-oriented control, where we saw a field-oriented control synchronous motor made in the 70s with a giant, like, it wasn't a tape memory computer, but it wasn't far off. It was a 286 or something like that. And the professor we had he was really cool, but god damn, teaching field-oriented control on a 1970 era gear is just crazy. We had a course about switching converters, so bucks, boosts, flybacks, stuff like that. So and we started with a triac controller, like a phase angle firing controller, and we stopped at a boost. We didn't do anything more than that. So go figure. Electronics there was only one semester about electronics, and it was about operational amplifiers, and that was it. So we started. The professor was really nice. I actually liked him. So what's a diode? What's a transistor? What's a JFET? What's a MOSFET? Here's what an op-amp does. You figure the rest out. So I didn't do much electronics formally in university, but I know a bit of electronics from, the art of electronics and other stuff like that. Get on with the junior. God damn it! What is my point? My point is, don't. I wouldn't advise to study in university in Romania right now, especially not the one I studied. I would go to something else. So avoid electrical engineering, and this is from an alumni. So, at work, we had a cooperation between the university and the faculty of electronics, and this is my own opinion, so it's not representative of my employer, which you're never going to find out who my employer is. This is my own opinion, and I'm speaking as the person who went there immediately after the guy who works for my employer finished his job, and was talking to the students there. So they told me that they had the same problem. They had 2 years of pandemic, so off online courses, and for an electronics university, or for any university, any technical university, it's very hard to do, because you need to get some physical aptitudes, like hooking a crocodile clip on something, soldering. They didn't know how to solder. How to measure something with a voltmeter, how to measure something with a current meter, like using a multimeter basically without killing yourself. And they didn't have any of that. And it's very sad. And I hope something is going to change very soon, because otherwise we're going to have to do a lot of hard work down the line. Point in case, they had to do some basically some voltage regulators, and there was this one girl whose schematic worked very well, so it was a testament to her simulation skills and the thought that she put into the thing. So when she laid out the circuit, they actually had PCBs made, so she didn't put the components where you'd expect them to be put, like one next to another, where you need them to have the shortest traces you can get. No, she put all all the capacitors in one side, all the transistors in one side, one solitary diode in the rest in the bottom left, and the resistors in the top left. So her PCB was like a rat's nest, and it worked perfectly. It actually did work really well, as intended. But here's a quick saying hi to all the kids at university. I hope you're gonna do very well for yourselves. So don't do university in Romania. It's not really worth it, in my opinion. The quality of the education is far too low. But yeah, I'm an opinionated son of a bitch, so do with this information what you please and take it with a grain of salt. I'm also very bitter about the university experience I had because I've heard about how university is in other countries, and I regret not going to university abroad. I like this country, and I like where I work, and I like what I do, and I like most of the people around here. But one of my biggest regrets is not actually studying abroad, because I could have done much more with my time. And yeah, so I think that's gonna be it. It's another 20 odd minutes of me just talking to myself. I think I'm doing it. I think you guys are all my therapists. So, yeah. Anyway, thank you for watching. I'm going to have to go wrangle some cats, and I'll see you next time. Bye bye.